In this video, we are going to do these two questions from the chapter limits and derivative. And we are going to use these standard limits for solving these two questions. Let's begin with this question first. In this question from NCRT exemplar, right, we have to evaluate this function for limit extending to 0. Now, in order to solve this question, we are going to apply number one is half angle property. Right, and we are going to convert 1 minus cos x as 2 sine square x by 2, and then we'll be applying this sandwich formula to solve it. Now let's begin with the first step over here. So we'll write limit x tending to 0. This is x square cos x. This is x square cos x. That divided by 1 minus cos x. So what I said here is to convert this 1 minus cos x as 2 sine square x by 2. So this is limit x tending to 0. This is x square cos x. And this 1 minus cos x is what? 2 sine square x by 2. Now we'll do some rearrangement here. So we have limit x tending to 0. I can write this as what? This is x square. I can write this x square over 2, right? This is, and that divided by sine square x over 2 multiplied by cos x. Now, as you can see that in order to apply this sandwich formula, we need same angle. And that's the reason why I'm going to multiply by 2 and multiply and divide it by 2. So I can write this 2 outside the above one, and then it becomes limit x tends to 0. This I can write as what? X over 2 whole square, and this as sine x by 2 whole square. So together I can write this as, and then I can apply a separate limit for cos x, that is limit x tend to 0 and cos x. Now check here, we have 2 outside here, and this is going to be 1. This is 1 because of the sandwich formula, and cos 0 is 1. So therefore we can say 2 is the correct answer, and that is option A in this case is correct. In the next question, we have to evaluate e raised to the power x plus e raised to the power minus x minus 2 over x square where limit x tends to 0. And for solving this, we are going to apply this identity, that is e raised to the power minus x minus 1 over x is equal to 1. The first thing that we will do over here is to write e raised to the power minus x as 1 by x. So let's say if I do it, this we have a limit x tending to 0. This is e raised to the power minus x, and I can write this as 1 over e raised to the power x minus 2, that whole divided by x square. Now check if I take LCM over here, what you can see, the LCM is going to be e raised to the power x from this. So I'm taking LCM. So this one multiplied by this is e raised to the power 2x, right? As you know that e raised to the power x into e raised to the power x can be written as e raised to the power 2x. Applying laws of exponent is what I'm talking about. So once we got this, what else we have is plus 1 and minus 2 e raised to the power x, and as I can see we have an x square as well over here. So let's say be x square, right? Now next what we are going to do here is to, let's say if I remove this space, can I write this as applying a minus b whole square? If you watch it carefully, you will see that this is a square, this is a square, this is b square, and this is minus 2ab. So this way I can write this as what? E raised to the power x minus 1 whole square, right? This is, and there is an x also below, so I can club them together to write a single square over here. One more time, this is actually a minus b whole square, that is ex minus 1 whole square, and below it was x square, so I wrote it like this. And this is limit x tending to 0. Let's say if I apply another limit for the other part, limit x tends to 0, and this is e raised to the power minus x, right? It was in the denominator, so in the numerator it's going to be like this. Now, as I said over here that this limit, this is going to give you 1, right? This is going to give you 1 after applying limit. So 1 square is 1, and this is e raised to the power 0, right? And minus 0 is 0 only. And you know that any number raised to the power 0 is 1. So 1 into 1 is 1. Now we have an option that is A is the correct option in this case.